Good afternoon, respected committee. We are Neumann 2.0. In this video, we are going to present our senior project 2 proposal, Smart Resu, an AI-powered resume analysis and rendering system for Japanese recruitment team. I am Metari Tamakan.
And I am Parapat Tabata. Here are the list of topics. The Adecco Group is a Swiss-French company based in Zurich, Switzerland. It is the world's second largest human resource provider and temporary staffing firm. We are working with a Japanese team of the sales department of Adecco Thai branch named Adecco Recruitment Thailand Limited. He inquired about the possibility of automating some of their work processes. We respectfully submitted our idea to him, and we are delighted that he is interested in working on this project with our team. At the moment, he is working on arranging a meeting between his boss and our team for the middle of September. It has been brought to our attention that a challenge that their team is facing is that when they receive resumes and documents from their candidates, they always convert them into their own format. They do this process manually, which can be time consuming. Thus, they still have tons of resumes not converted. And their team does not have a database supported by any platform due to legal concerns. I believe that all of their data is stored on their hardware devices. Therefore, they would prefer that the resume conversion system not to be stored, but rather be used for a specific purpose. Here's the resume they receive. Japanese resumes usually follow a template that is provided by the Ministry of Labor. Although there can be minor differences person by person, the overall format is not vastly different from the government-provided template. Together with resume, Japanese people attach document with details of their work experience. Although it can vary depending on their specialties, it is not so far away from the given template. Here's the desired format provided by their team, and we notice that it is the mix of those two documents.
The problem is that reviewing resumes manually takes a lot of time, and the number of resumes keeps increasing every day. However, each resume has a different format, which makes it difficult to compare the skills and the qualifications of applicants. Moreover, when entering candidate information into the Adecco format, there's a risk of typing errors or placing information in the wrong fields, since it is repetitive work, but the content is not exactly the same. Similarly, mistakes can also occur during the checking process. Our idea is a smart resume scanner using NLP to process Japanese resume. User upload digital PDF format into our system, then we use library to extract blocks, including text, table, and layout information. After that, we apply document layout analysis to analyze relationship of each block as header and subgroup into JSON, and convert to canonical JSON of Adecco format and render it as a document. And here is the overview of our 5 steps methodology, where we're gonna dive into the technical details for the next slides.
Here's how our system works. First, a salesperson receives and uploads resumes on our system. Then our system will render a document and any possible issues with generated document, which user can observe, edit, and re-render. First process is to extract necessary information such as text, tables, and layout information for the layout analysis. Table heuristics, which works great for a Japanese resume that has a lot of text and tables. Although it is slightly slower than other libraries because it builds on top of PDFminer.6, it is although it is slightly slower than other libraries because it builds on top of PDFminer.6. It is much more user-friendly and easier to manage. Next, we apply document layout analysis to understand the relationship of each block and convert them into related headers and subgroups. We are going to be testing with two approaches, compare each model, and use whichever one works better. First one is rule-based approach, where we group headers and subcategories by keywords and applying heuristic rules such as font size, boldness, or position if necessary. The reason for this approach is that Japanese resume format is very limited and not so distinct from one another. Another approach is to fine-tune a pre-trained model named Layout LM version 3 for the case of when each resume is unexpectedly different and hard to identify the rules. Layout LM version 3 provides contextual embeddings which know text meaning and the layout structure to identify headers and the relations. Although other models also support Japanese, they are very limited, unlike Layout LM version 3. Some models like DIT, Donut, Pix2Struct, or UDOP have optical character recognition built in, meaning that it works with scanned PDF and not with the digital PDF. After the document analysis, we perform format conversion. We parse each section into structure records to be ready for rendering. And during this process, we might have to normalize them into their format like dates, era, and suffix. We also have validation checklists like if some necessary information is missing or something does not make sense, and we report this as a potential issue when rendering. And finally, we convert the canonical JSON into a document using the library named docs.tpl.
And here is the application flow. So user begin by uploading folders containing candidate resumes. When user decide to convert, our system automatically extracts the candidate data and maps it into the article template. The user reviews the pre-filled article form, corrects any mistakes, and approves the record. Once approved, the system renders the final article format file. And here is the user interface example. On the main screen, the user starts by uploading resumes. They can either select multiple .pdf files or upload a zip file containing several resumes. Each upload is limited to 50 megabytes to keep processing smooth. Once the files are uploaded, the user clicks Next. At this point, our system automatically extracts the text and organizes it into the standardized article resume format. The user is then shown a preview screen for the structured article format with fields like personal information, education, work experience, and skills. If the system places information in the wrong field, the user can easily edit directly within the article form, for example, correcting a job title or adjusting dates. After reviewing and making changes, the system generates the final article formatted resume file ready for download or export. As for our expected outcome, our system begins with accurate text extraction from digital PDF resume, ensuring candidate details are captured correctly. This leads to the next outcome, which is well-structured resume sections where information is placed into the article format for easier comparison. From there, resumes are rendered accurately, and any small errors can be fixed quickly in the editor, supporting faster corrections and smooth approvals. Together, these outcomes deliver less manual work and higher accuracy. And here is our timeline throughout 4 months. In the first month, we will focus on research and data set collection while also getting familiar with the libraries and NLP tools needed for the project. In the second month, we'll move on to the detecting layout sections within resumes and testing these methods on sample files to validate our approach. By the third month, we'll develop the NLP pipeline and integrate it with the extracted information to build the core functionality of this system. Finally, in the fourth month, we'll conduct testing, evaluation, and refinements, making improvements where needed, and then prepare our final report and presentations. And these are our reference links. Thank you for listening.